won't make you do this table. This part, I'm pretty sure they won't make you put it in a calculator. If you put it in a calculator, you're gonna have to use programmable calculators, or they will give you a table themselves in the exam. All right?
Yeah, we're not allowed to use calculators at all.
Okay, so if you're not allowed to use calculator, then the table will be given to you, like this one here. Yeah, right.
Yeah.
So then we are saying here, guys, we're making T1 equals to, we make it 1. And then we say, okay, because we want the delta T to be closer to 0, because delta T is T subscript 2 minus T subscript 1. Now, watch when I solve for T subscript 2 so that it makes sense to you, instead of applying direct. It's the same as T1 plus, remember, this one has to go to the other side. It's T1 but plus delta T. Can you see that?
Yeah.
Yeah, so T2, it's actually T1 increased by a certain amount. That's what delta T is. All right.
Yes.
Yeah, so that means that delta T, the increment, we make it almost closer to 0, because there is a table here which will save us time. That H there, it's actually the delta T. Let me change it here for you. It's actually the delta T. And then here it's where we're having T1 is 1. All right?
Yeah.
Yeah, this one is for the other one. We don't need the other part. So what's happening? We're saying, oh, all right. So we are working between T1 equals to 1 and T2 equals to, what is T2? The first thing they did, they increase it by 1. They make delta T to be 1. You need to have like a couple of values. So that means if I increase T1 by 1, T2 will be 2. We good, right? Then I must have T1, get the Y1 value there. Then I must have T subscript 2, which is 2, and get the Y2 there. And then now I want to have a 0 at the bottom. Then you do your calculation, like how we did the grade. It's going to work out in this case because, okay, this one, of course, you're getting a 16, and then the other one is a 64. We good, right?
Yes.
Yeah, so to get instantaneous, you have to work with an average, but make the delta T values closer to 0. Just have a couple of those values, because you're not using calculators, they'll give you the values. So now, when you work out the first one, the first answer will be this one. You'll get 48. Now you say, all right, fine. Because I increase it by 1, let's make 1 a little bit smaller to get closer to 0. That's why I think you have seen it later. You'll see, that's why we say delta T approaches 0. It gets closer to 0.
Yes.
So the next value they use, it was 0.1. So that means T1 will be 1. And then the T2 is going to be 1 plus 0.1. So it's going to be 1.1. And then you're going to have to get the Y2 there. You're going to have to get the Y1. And again, you won't get the denominator to be 0. You work out the gradient, that average grade, you get this number there, 33.3. Is it making sense what I'm saying? Then delta T, you further make it a little bit more closer to the 0. It becomes 0.0. And then the next one 0.000. The next one 0.0000. The next one 0.000. You keep on adding. As you're working out the gradient, you are going to see a pattern. A pattern starts to show up from here. The blue ones. You see the blue ones that I'm underlining?
Yes.
It's like they repeat themselves. Look at that. 32, comma. The next one 32, comma. The next one 32, comma. So what is consistent on these three? It's a 32. Can you see that?
Yes.
So that means the true answer then, the true answer at T equals to 1, it means that average speed will be the 32 without actually substituting that value that gives you a 0 undefined. So it's going to be 32. I almost wrote meters per second, but it was also fine. It was be feet per second. So let's recap. What did I say? Average gradient, you give me 2 points. Two different points. Let's call it 2 different points. Instantaneous or at, it's actually 1 point, or you can say 2 points of the same. You know, they're the same. Yeah, but you're going to have a problem. You're going to get 0. So you can't do it direct. You have to borrow the average method to get this instantaneous. So what am I going to do? I'm going to make sure that that t that's given to me, I'm going to increase it by values which are much closer to 0. I'm going to increase it by 0,1, increase it by 0,001, 0,0001, 0,0001, whatever. Then I can work out all my average gradients, maybe 5 of them or 6 of them or 10 of them, and then boom, a pattern will show up. There will be a number that will never change in those averages gradient. That number that never change, that means that would be the answer for the instantaneous. Are we good?
Yeah.
All right. So now let's go back here. Instantaneous, remember, we usually say at, let's say t equals to something. So instantaneous, it means you are given 1 point. You're given 1 point. So that means if you have a curve, your graph, it's a tangent. I'm just telling you ahead of time. The tangent touches the graph at 1 point. So instantaneous is the one that we call the tangent. That's why they'll call it the gradient of a tangent. And they'll say at a point. All right. So what did I say? I've covered it. Don't worry. Average, give me 2 points. I can work it out directly. Instantaneous, 1 point. I can't work it out directly. I need to borrow the method of average and work out some average, whatever speed. Then there will be a number that will be repetitious. That means that number is the answer for my instantaneous without calculating instantaneous directly, because directly I get undefined. I hope it makes sense to you.
Yes.
All right. So there we go. So now I think we have covered